Okay, so we're going to talk about graphing rational functions today, and this is lesson 4.4, examples number 7, 8 in our pre-calculus book. And so we're going to analyze the functions algebraically, determine its vertical asymptotes, holes, and intercepts. We're going to determine the end behavior of the graph, so that depends on the degree of the numerator and the degree of the denominator. If the degree of the numerator is equal to or less than the degree of the denominator, we get a horizontal asymptote, and otherwise we'll get a different type of asymptote. And then we're going to use that information to graph. So here's our first function we're going to work with is y equals x minus 1 over x squared minus x minus 6. And the first thing you're always going to want to do is to factor the polynomial first, of this rational function. And so when we factor this here, we've already shown it here. And then we're going to find the zeros, or the x-intercepts. And the y-intercept will be the second thing we do. So we'll look at those two things first. Zeros, once again, is when the numerator is equal to 0. So in that case, this is 1. When the for the y-intercept, then we're going to look at the constant term. So here we've got a constant term of -1. Here we have -6. So we have the numbers 1, 6 as our y-intercept. Okay, so after we find the y-intercept, then we're going to look at the vertical asymptotes. So here we'll write down vertical asymptotes. And reminder, that is where the denominator is equal to 0. So in this case, we have two of them. We have 0 when the denominator is 0 for the factor x minus 3 and for the factor x minus 2. So we'll have our vertical asymptotes will be x equals 3 and x equals -2. Now the last thing then we're going to look at is end behavior. And end behavior could be a horizontal asymptote, or it could be an oblique slant asymptote, or a parabolic asymptote. So we're going to look at just the largest terms of the numerator and the denominator. So we're going to look at x and x squared. And when we focus on them, x over x squared, that'll reduce to 1 over x. So that gives us a horizontal asymptote. And I'm just going to abbreviate that as HA. And so we will write this as equation y equals 0. So now we've got all the important information, so we're going to go ahead and graph it. So we start with our zeros. We have a 0 at 1. We mark that dot on there. And then we're going to put our asymptotes next. So we have vertical asymptotes at x equals -2. So we draw a vertical line there, and x equals 3. And those are dotted lines because they're just showing us where those breaks in the graph are. And then we have our horizontal asymptote at y equals 0. So notice that we do have a 0 here through our horizontal asymptote. And that's okay, because when we talk about horizontal asymptotes, we're talking about what happens when x is really, really small and when x is really, really large. So having a 0 there in the middle is fine. So now we'll look at the y-intercept here for our graph. We got 1, 6 there. So because we have that y-intercept there, that tells us our graph is going to have to come from positive infinity down through the y-intercept, through the 0, and then the negative infinity. And we have the boundary of the vertical asymptotes, so we know we can't cross them. So our graph then between there is going to look like this. And there will be part of our graph. Now on each side of the asymptotes then, we've got over here on the left side, since it goes to positive infinity on the right side, that means it's going to come from negative infinity on the left side. So we're going to draw the graph. We'll go in here. Since there's no zeros, it can't cross the x-axis. So this graph will come up in here. And then over on the other side of this vertical asymptote, the graph goes to negative infinity on the left. So then it's going to have to come from positive infinity on the right. And so that graph will look like this then. And it can't cross the x-axis. And so that completes problem number 7. Okay, and so let's look at another one down here. We have number 8. We're going to graph this rational function here. And you can see once again I've gone ahead and factored that, and that's the first thing you always want to do is go ahead and factor it. And so then we're going to, once again, we'll put down our zeros and our y-intercept. So the zeros in this case, it shows we would have -2, +1, +3, but the problem is I have a common factor of x plus 2 in both the numerator and the denominator. And that common factor there tells us it's a special situation because we can't have a 0 and a vertical asymptote at the same time. So that tells us that there's going to be a hole in the graph, and that hole is going to be at where that 0 or vertical asymptote would be at -2. So in this case, we have zeros at +1, +3 for those zeros. And where the denominator is equal to 0 here, we're going to have our vertical asymptote. I'm just going to use VA to represent that, and that'll be x equals -1. And then not forgetting our y-intercept, we have 6/2 because we're just looking at the constants, and that would give us 6/2 is 3. So we have our zeros, our y-intercept, where our hole is, our vertical asymptote, and then we have our end behavior we have to look at. And in this case, we have the degree of the numerator is 3, degree of the denominator is 2. And if we simplify that function, or that fraction, we're going to get just the value of x, which means it's going to give us a slant or oblique asymptote. And so when we're looking at them, we're just going to focus on the x minus 1, x minus 3, and the x plus 1 to find it. So if I rewrote those, we would have x squared minus 4x plus 3 when I multiply or FOIL the numerator over x plus 1. So then we're going to use synthetic division to find our end behavior, which is a slant asymptote in this case. So we'll put our -1 in our little box, and 1, -4, and 3 are coefficients for our numerator. So we'll bring down the 1 first of all. -1 times 1 is -1, so we get -5. And -1 times -5 is +5, so we get 8. But when we're looking at our slant asymptote, we don't care about the remainder, so we can cross that out. We just care about these two here, which would give us the equation y equals x minus 5. All right, so now we're ready to graph it. So we'll go ahead and graph our zeros first. And so we have zeros at 1 and 3. And we have our vertical asymptotes are at -1. So the vertical asymptote here at -1. And our y-intercept of 3. It's about there. All right. Now we have our hole, it says, at -2. So let's figure out where that hole's at. So we're going to take and put -2 in for x into this part of the function, right, to find out what the y value would be for that hole. So in the numerator, we're going to get -3 here, -5 here, and -1 there. So -3 times -5 is 15, divided by -1 is -15. So our hole is at the point -2, -15. So we're going to actually put a hole there in our graph. And let's look at our rest of our asymptotes. And we have our end behavior. We have the slant asymptote. Y equals x plus minus 5. So we have a y-intercept here at -5. And if I go up 1 and over 1, I'll end up with it going through here. And so we have this asymptote right there. And so our graph then is going to have to come down here, go through the y-intercept, through the zeros, and then it's going to follow the asymptote right through there. And then that's the same on the other side then, also over here. We've got to follow this asymptote, go down through the 0, and then follow the vertical asymptote. And remember, since it's positive infinity up here, it's got to be at negative infinity down there. So our graph then will look like this. Come through here, come down through the hole, and down to positive infinity. And there's our graphing our rational functions.